And here's another one to try now. So remember, any physics you know on the topics mentioned in this question. Okay, so that's definitely less scary than the one we looked at in the earlier video, but nonetheless, you might think, how do I get 6 marks out of this? This is, note, an old specification question, and that's why the marking was a bit different. We're going to try and mark it approximately according to how it would be on your specification now. Okay, so what we've got is describe this fusion process and compare the energy release with the energy released in alpha decay. So let's start with the fusion reaction. So we can say that we've got smaller nuclei being stuck together into larger nuclei, which releases energy. That energy is equal to the mass defect times c squared. For fusion to happen, we need high temperatures and energies to overcome the electrostatic repulsion once again, and that's to get them close enough to get these positively charged hydrogen nuclei close enough together that the very short range strong force can take effect. And that's good. If you notice the positrons in what they've told you, you could also say, because we know why they're there, we could say that they're made in weak interactions, and we could say that we have to conserve charge in this reaction, and so we need +4 charge on the right hand side as well. I put that in brackets because that's sort of less important, less essential. Okay, now for the alpha decay. That is when a large nucleus decays by emitting an alpha particle, and an alpha particle is 2 protons and 2 neutrons. Okay, at that point, if you've got most of that, again, you're on sort of 3, 4, probably 4 marks at that point. Okay, and now to directly compare them, what can we say? Well, the energy given out in the fusion reaction is much, much bigger than the energy given out in the alpha decay. And that's because a lot more mass goes missing. It must be. To have more energy given out, it must be that a lot more mass goes missing overall. Or you could say that the difference in binding energies is bigger for the fusion reaction. And you don't need all of that. If you had sort of most of that explained reasonably well, you're still on 6 marks there. Okay, we're going to keep practicing this skill, but remember the strategy is write down any physics you know that's relevant to the topics that are mentioned in the question.